You're welcome. So today I'll be discussing altering product strength or changing the strength of products or pharmaceutical products. I always remain Wilson. The objectives of the sessions would be introduction or key definitions, types or the formula used in dilution, the C1V1, and we shall also perform or illustrate some examples which have been answered or attempted. So the product strength may be altered, that is increased. All of us know what the meaning of altering means. May be increased or decreased by changing the proportion of the active pharmaceutical ingredients or even other ingredients. Yes, this one is key. That if you're having a product in a beaker here, you can change its concentration by either adding or you can either increase it or decrease it. Dilution, we shall basically talk about dilution of liquid dosage forms, even other dosage forms, may provide a product of a desired concentration for use by the patient or for use in the preparation of other products. Dilution. In dilution, we always use a diluent or a solvent, and which should always be compatible with the original product, or you can use a product of a lesser concentration. For example, if I'm going to dilute ethanol or anything else which is water soluble, I shouldn't use oil as a diluent because it won't be compatible with our product and we shall not achieve what we wanted. So the diluent or the solvent used should be compatible. And of course, the product strength may be increased by addition of more active ingredient or use of a product of a higher concentration. Use of a product of a higher concentration. So that one, of course, if you're having a product in a bottle, in a beaker, you can increase its concentration by adding more reactive, or you can dilute it with more product of which is more concentrated. The diluents used, as I have said above, they have to be compatible with our product. Purified water or distilled water, water for injection, sodium chloride 0.9% weight per volume, or dextrose D5 weight per volume percentage. Now, as I keep reminding us that the concentration of diluent such as sodium chloride, this is concentration 0.9% weight per volume, and dextrose 5% weight per volume should not be considered in the calculation, because some people always get confused if you get a question and there are very many concentration, which one to use, which one not to use. Those ones of the diluents are not considered. You just use the other ones which have been given to you or told you. Now, in the pharmacy, we have these concentrated solutions, or called stock solutions. I remember in high school we had them. The lab attendants always pick them in those uh, dark yellow or amber color, the big glass containers from the cupboard down. Now, again, we also have them here, these stock solutions, that these are concentrated solutions used in preparation of products of lesser concentration. Stock solutions are basically used in the pharmacy laboratory, in other laboratories, to save preparation time of the product since it's already prepared for us, to reduce storage because I want you to use a bigger quantity. I just prepare from this one and I use there, and then I'm saving more storage space. And also to improve accuracy since it has been prepared for us, we shall limit the number of errors. When a product is diluted, this statement is important. The quantity of the active ingredient remains unchanged. However, the concentration of the ingredient changes. So this statement is key. And you are going to see how you can attempt some of these questions, because if you receive a question and then you illustrate it to understand it better, you'll easily understand the question. But if you don't illustrate it, then you just be there in air. But if you illustrate that statement, for example, this is before dilution. I'm having A, B, C. I've just labeled them. Then A is the stock solution. Then B has been drawn from A. I've removed 10 mils. So it means that since I've removed it from this one, they have the same concentration of the active. However, the quantity of the active inside here is different because of different volumes, as you can see. This one is more, this one is less. So A and then B have the same concentration of the active, but A and B have different quantity of the active. So if I dilute after dilution, I transfer B to C in this purified water, as you saw here. It means that B and then C have the same quantity because there's nothing I've added there. They had the same quantity of the active, but they have different concentration because of different volume. So it is the opposite of the other, and you can just look at it and then interpret it from there. So let's continue. So a dilution is a simple method of preparing a solution, a product of lower concentration from a solution or product of higher concentration. And these are the dilutions that we can talk about. The basic dilution can have multiple dilutions, serial dilution, and also the alligation, which you are going to look at later on, or the mixed concentrations, these allegations, where we are using different products. Here we use products to dilute or increase the concentration. So in simple dilution, this is the commonest one used. Simple dilution, the method used in dilution and concentration, the equation C1V1 C2V2. You can write this equation, or you can use first principles by determining the quantity of the active ingredient present, required, and then later on doing further calculation. You can see, if you look at the question, you can easily work from backwards, then you go to front where they came from. If you're using first principles, then the quantity of the active, then doing the relation, and then calculating the quantity of the other that is required, which you are going to explain in the slides. So this equation is key, and you have to understand it. C1V1 equals C2V2. V1 volume of the stock solution needed to make the due solution. This one, C1 is the concentration of the stock solution. V2 final volume, and then C2 is the final concentration. So this one, we have to understand this formula, and then we shall understand how to use it. C1V1 equals C2V2. I have an example here for us. If 250 mils of 15% volume per volume are diluted to 1 liter, what will be the final concentration of the product? So always, if you just look at this one, I'm having V1, C1, and then V2. This is I'm looking for C2. Now you have to state this formula for us. Define the variables or define the terms. V1, C1, V2 1 liter, convert it to mils because they have to be in the same units. I'm looking for C2. I just input it in the equation. Now, we use the figure. We don't use the percent here like what I had put. We just use the figure, because even the concentration will have the percentage. So we don't consider 15% or 15 out of 100 here, but we use the figure 15 because even this one will have the same units. So you just solve the equation and you get 3.8% weight per volume. If weight per volume, you have to give us the units for easier to see what you're doing, also know what, understand what you are doing. So you can pause the video and then try to review, try to calculate it yourself. So I'm having example 2. This was supposed to be example 2. Supposed to be example 2. Example 2. So how much drug should be used in preparing 50 ml of a solution such that 5 ml diluted to 500 ml will yield a 1 in 1000 weight per volume solution? So this is like how I demonstrated above in the stock solution. If you see such a question, it is important you demonstrate, because if you demonstrate like this, you also understand what you are doing. Some people always get confused when they read the question, then they just look for things and how to start. But if you just demonstrate that question, they said how much should be used in preparing 50 ml. So if I call this one A, 50 ml, such that 5 ml, this one be from this, diluted to this one, we'll use this. So it's good you first write them like this. You know, you don't draw beakers, but you got just columns. It is important. Define these variables. This will be V1 or V. You can just use V, or you don't put V1. Here could just put CV also, and then CV. Later on, you can define the 1 or the 2 later on. But it's important you convert this ratio to a percentage, because all these are marking points. So as we said before, that A has the same concentration as B, then A has different quantity as B. So this is like what we did before. So B has the same quantity as C, but B has different concentration as C. So if you do these ones, then the question is very easy. Method 1, I will use concentration, for example. Method 2, I will use quantity. So now, since I'm working from this side and then I have the one of C, I can write these equations V1s, and I can work from backwards from this side to this side. So I'm having V1, I call this one V1, which is 5 mils. I'm looking for its concentration. V2 is this 500, its concentration I calculated at 0.1 weight per volume. I just input it in the equation. Then my C1 will be 10%. But you have to tell us the statement that B has the same concentration as A, or 5 mils has the same concentration as B, because this one was drawn from this. So to get the quantity of drug needed in A, just use a percentage. 10 out of 100 times 50, it will be 5 grams. Because they want how much drug should be used in preparing. So this 5 grams will be used in preparing the 50 mils. Now, you can pause and then review. The same question can be answered using quantity. If I use quantity, it is always important to first convert to percentage. Me, I used 1 gram, but also if you use percentage, you have the same answer. So 1 gram is 1, I use the ratio, sorry, but if you use percentage, you come up with the same answer. You first try that one with the percentage, If I say 1 gram is in 1000 mils, but let me use the percentage to be easier for us. 0.1% it is weight per volume. Weight per volume. If I interpret that and I say 1 gram is in 100 mils, then 500 mils will contain this was 0.1. Make that mistake. 0.1. So all of us will have the same answer, whether you use a ratio or a percentage, but it's good to use percentage, not like what I had used. Not like what I had used, sorry, it has. So it means that 5 grams, which is in 500, is the same as what is in is 5. So now here, you can just use first principles. If 5 mils, let me remove this so that we follow together. You say if 5 mils contain 0.5 grams, what about 50 moles will contain maybe 50 to be 50 times 0.5 over 5, which gives me 5 grams. So this 5 grams will be the one we used in 500, sorry, in 50 mils. Sorry for the pronunciation and the broken English, but always forgive me for that. So this has been a short presentation. Thank you for listening. If you have more questions, now go Classroom app and please try to review them. They'll be better for our understanding.